So stuff like this will be on the test, right, in various forms. Just be able to look at a diagram and draw your precision from it. And so this one is in centimeters. So you have options, right? You can say that the precision is 1 millimeter, or you can say if you count the gaps, right, that it's 1/10 of a centimeter, which is 0.1 of a centimeter. Either one, right? You're technically saying the same thing, right? So I will honor both, but if you state it as a millimeter, then your uncertainty is 0.5 of a millimeter or 0.05 of a centimeter. Okay. So that's that. So you get 1 mark for the whole thing. Let's go to B. This one you should know by now already. It's in inches, right? So you just go 1, 2, 3, 4, 5, 6, 7, 8. By now you should know that this will be 16, right? Because if you go to a halfway point and it's 8, then it's another 8. So yeah, the precision is 1/16 of an inch. And if you want to state that as a decimal, that would be 0.0625 of an inch. Right, it's up to you. And so the uncertainty would be 1/32 of an inch, or half of that, right? So if I split that in half, I get 0.03125 of an inch. So just count how many there are from one number to the next, and that is your precision, right? C, right? You go from 5 to 6, right? 1, 2, 3, 4, 5, 6, 7, 8. So the precision is 1/8 of an inch. Or you go 1 divided by 8, that's 0.125 of an inch. But really, just leave it like that. So the uncertainty is 1/16 of an inch, or half of that, right? Just divide this by 2, 0.0625 of an inch. 1 mark for that. In this particular case, you can tell most of these will be able, it's mental math, right? So, you know, it's 150, 200, 250, 300. So we're going up by 50 milliliters at a time. So half of that is your uncertainty, okay? So just look at like how much am I going up by? And you know what the fail-safe method is? Fail-safe is subtract the two numbers that you see and divide it by the number of gaps. So let's say it's 200 minus 100, divided by 2 gaps, that will give you the 50, right? So if you're not sure, that's another, right? So you basically go max minus min, then divided by the number of gaps. That will get you your precision. So even if you go 400 minus 100 and you count how many gaps there are in between, you'll still get 50 every time. Okay, and then uncertainty is just half of that. Okay, let's go to our thermometer here. This one might have been a bit tricky, or no? 1, 2, 3, 4. No, it's 5. So our precision here is 10 degrees Celsius, and our uncertainty is 5 degrees Celsius. So this page is 5. Okay, 1 mark for each. This page is 5. You got to have it exactly, or it's wrong. Okay. Define tolerance using your own words. You can give a specific example as part of it, right? So you can say that it's the range of values, right? Range of acceptable values, sorry. Of acceptable values. You can say it's the difference between the maximum and the minimum. And if your parts fall within the max and the min, it's still going to be used for its intended purpose. I can, another variation, allowed for item to still be accepted. And on Friday, I talked about, think of it as it's almost like a funnel or like a pipe, right? And if this is the lowest acceptable value and this is the highest, if it falls outside of the lowest and the highest, if you measure and it's either smaller or too big, it's not going to be passing the quality test, right? So it has to be within, this is what we call the range, right? The difference between them. Okay. Yeah. That's not our definition of, yeah. It's on page 92 or something like that, tolerance, yeah. It's not between two objects, right? It's what's allowed. It's the leeway. Yeah, you can, I would say leeway. Yeah. Because this is not two different objects, it's just what is allowed, right? Like it's between here that it will pass the quality test. And we talked about that on Friday as well. We did some examples on samples that I gave them. I'll give you a little sneak peek of that. So let's say you're, this is what this production line, you're making washers, and the thickness of the washer has to be between this and this. And so let's take a sample from the line at 2.0. It's within, so it passes, right? Sample 2, it's 2.15, right? It's bigger than this, so would not pass, right? 167, it's just slightly smaller, wouldn't pass. 2.1, if it's right on it, it would still pass. So it's inclusive, okay? All right. In each case, state the nominal. Give specific examples, sorry. If you wanted to give a specific example, I always like the prescription drugs, right, that I talked about on Friday as well. If it's too low of a dose, it's not going to do anything for you. Like if Tylenol, if I take one Tylenol and I have a headache, it's not going to do anything for me because I'm a big guy, right? If I take too many, then you can have side effects, you can overdose, blah, 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 right? So you kind of want, like, so the tolerance allows for some variation, but you can't be outside of it or else there will be negative consequences, right? I did? Okay. And then, yeah, the COVID vaccine, right? It's 0.5 ml, that's what it is. I looked it up. Is a dose, 0.5. I still think that for me, that was probably pretty low, right? But whatever. I think it does what it needs to do, right? Anyways, here. In each case, state the nominal, minimum, maximum. So nominal is always the big number up front. So I'm kind of speeding. I'm just going to give you the answer. Otherwise, it's going to take too long, okay? So for each case, it's the big number up front that is the nominal. So check mark if you got that right. So let's just check all the nominals. If you two marks, 2 ticks is inches, 1 is feet. I don't know if I mentioned that ever, but I'm pretty sure at this point you should know that. But make sure you attach that. So this is where it differs, right? In this case, the max, right? You add whatever that top number is to get this. We subtract 0 basically to get, so in this case the nominal and the min is exactly the same. Yeah, Kimji. This is wrong. D. It's 1, 2, 3, 4. 1, 2, 3, 4. So the 6 just gets added to that 0, right? Oh, okay. I see. Yeah, good eyes. And it's supposed to be like this, right? Yeah, my bad. I see. How about you just check it over, and so for example, when it's stated like this, to get your max, you just add, to get your min, you subtract, right, from the nominal. If it's like this, so you don't see the half, do you? That's okay. If it doesn't show like that, I will probably not ask you to figure out much else. But you could still, in each one of these cases, guys, you should be able to figure out the tolerance, correct? Max minus min. Go ahead, Lawrence, question. No, because it's minus 0. It's the same, right, in this case? Yeah. It's the same. I truly believe that this is one of the units that if you miss this part, you should still be able to answer it, to be honest. Here I just look at, oh, max looks like the biggest value. There's a plus there I'm going to add, right? So there it is. So you get 5 marks if you get each question completely right. And then for 4, again, this is the one they gave me. And you don't see the half, right? You don't see the half. So you can't call the 0.5 your tolerance. You see that? It's not exactly like the 1/2 in front. So what you need to do is you need to get your min and your max. I kind of flipped it here on you, but it's still the same steps. Min and the max, right? And the tolerance I just got by subtracting these two. So it's 1 millimeter. And the nominal is obviously always the front number if you have it. And then based on this, I state it in the 3 other formats as per your study sheet. Okay, so those 4 formats, which are on page in the 90s, somewhere in the 90s, those were the good years. 92, on page 92, you'll have all 4 formats at the bottom there. I would strongly encourage you to put that on your study sheet. Okay. Okay, so 10 for the back side, 5 for the front. So we're out of 15. Back, yeah. So if you're scratching, but if you're scratching your head a little bit, like what happened, I feel like I missed a day, right? If you did miss Friday, check the lesson. I did go over this. Yeah. No, it's okay if you didn't give an example. If the explanation is what I'm looking for, if it touches on the fact that it's like the lowest and the highest permissible value, then I'm fine. Yeah.
For number 4, the tolerance is 0.1 because 0.5 would be the 1 divided by 2.
Yeah, in this case, I got the tolerance by subtracting the min and the max because this didn't have the 1/2 in front of it. If it has the 1/2, then this is the tolerance, but in this case it wasn't, so it's a bit of a sneaky example. Yeah. So I would say if you're not sure, find your max and your min and then subtract the two to get your tolerance. Then you'll be right every single time. Okay, so one of these I will return tomorrow. I think this one I will return. So just add it up, 10 and 5 to make it out of 15. And maybe I will say this. If you weren't here on Friday, I'm going to ask you to do this, and I think I posted the answer key, but there's a tolerance worksheet on page 11 of, it's page 12, but it doesn't have a page number, so you just go to 11 and then it's 12 and on. I posted the answer key, so if you need to practice this a bit more, you go for it, okay?